And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and we're starting things out looking at two coronagraphs. The LASCO C3 is the blue portion, the LASCO C2 is the red portion, as well as a Solar Dynamics Observatory 304 angstroms ionized helium animation of the sun to see a coronal mass ejection. This could likely have an Earth-facing component, although I cannot see sufficient information from Stereo A yet. The archival data is not yet visible, at least from the sites I've been looking at. So we can't tell for sure if this is Earth-facing or not. I would suspect that it is, and when it comes to forecasting, you're better off expecting the worst as opposed to expecting the best. Here's a close-up of the last 24 hours in 304 angstroms. This coronal hole down here is so well defined that you can actually see it in this wavelength. Very well defined coronal hole system, and there is a geomagnetic storm forecasted as a result of the incoming high-speed wind stream. We can expect that in 2 days on the 17th, according to the NOAA forecast, with which I would tend to agree. Here's a composite view. And I would note this active area down here, probably where the coronal mass ejection came from. And you're looking at three different wavelengths here, 335, 193, and 94 angstroms. Those are all ionized iron ultraviolet emission spectra. Here's another iron emission spectra, 171 angstroms. We do have one sunspot, 2833 up here. It's fairly uncomplex. It's got only North Pole-oriented umbrae, and the likelihood of producing major solar flares is quite low. In fact, I would forecast that that sunspot is going to degrade over the next day. Here's a little closer view, and there is a filament to the north of that. Great little filamentary region right here, showing up in ionized iron at 171 angstroms. And let's get through a bunch more data. We're putting out 3 videos today, by the way. There'll be a cosmology and meteorology segment. If you haven't checked those out, go have a look. You can find all of our playlists at youtube.com/smashamash/playlists. There is a playlist for daily space weather, meteorology segments, and cosmology segments. Here's 131 angstroms, a close-up of Sunspot 2833. It's large, although it's not that active, because it doesn't have opposite polarity umbrae. Here's a diagram of what's going on in the solar system. And there's where things are expected to be in a week. And here's a quick star chart for all of you astrologers, astronomers, etc. If you want to make your own, head to in-the-sky.org, put in your location. I've drawn in the ecliptic here, the path the sun takes across the sky. And we're located in Lehigh Valley, Pennsylvania. If you're up before dawn, you may see Jupiter and Saturn up there near the ecliptic. The 10.7 centimeter radial flux has bounced back to 77 solar flux units. Yes, the solar chromosphere and lower corona put out radio signals. Here's a 1-year chart of that. The black line here is the radio flux. Reported all the way down to 69 yesterday. Looked like erroneous data to me. Anyway, it's back up to 77 now. Sounds a little bit more reasonable considering we've got a large sunspot. So here's the NOAA forecast for incoming space weather. And you can see here early on the 17th, forecasting a G1 geomagnetic storm and a KP of 5 from the incoming coronal hole wind stream. So we'll be keeping an eye on that. And when I say eye on, the pun's intentional. Let's take a look at global seismicity here. Here's a 90-day chart from volcanodiscovery.com. The latest earthquakes, and we're seeing a lull of 6 magnitude quakes now. So a big lull in 6 magnitude earthquakes. I would say have an earthquake plan if you're in an earthquake prone zone. The likelihood of a 6 magnitude earthquake is quite high right now, as you can see how few we've seen over the past about 30 days. Only 2 in the 5 magnitude range, it looks like here, according to volcanodiscovery.com's map. And one of those 5 magnitudes was involved with a earthquake swarm here over the Caribbean, the Isle of Hispaniola, which consists of 2 countries, Haiti and Dominica, saw this 5.0 magnitude quake in between it and Puerto Rico here. We'll get to it on the list in a minute. It happened at 10:15 Universal Time yesterday. So there have been lots of Lots of aftershocks associated with that 5.0. Also, more activity off of the Oregon coast at a low magnitude. And we're just going to scroll up the list here. Again, if you're in an earthquake-prone zone, please have a plan, as there is a lull in 6 magnitude earthquakes. There was another 5.0 in the southern Pacific Ocean, a very desolate portion of the world near Easter Island. And here is a 5.7 at the Philippines. That was the largest of the past 24. It looks like that came in at 14:38 Universal Time yesterday, followed by a 5.3 magnitude aftershock. A couple of deep quakes came in yesterday as well. This one at 16:25 and this one at 17:04 at Colombia and Fiji, respectively. The depths of those mid-level 4 magnitude quakes, 150 and 462 kilometers depth, calculated at Fiji. Also a deep quake in the northern Mariana Islands, near the deepest ocean trench in the world. And if we miss anything or leave anything out, please leave us a comment. Let us know what we've missed. Fiji saw another deep quake at nearly 600 kilometers in the deep quake capital of the world, the area north of New Zealand, near Fiji and Tonga. Continuing on to look at volcanoes. We do it daily. Mount Etna is continuing to erupt. It's produced an ash cloud of unknown size. Karimsky on the Kamchatka Peninsula has produced a 12,000-foot ash plume as it explodes. Suwanosejima, 6,000-foot ash plume there. Luotolo, flight level 080, it's an 8,000 plume of volcanic ash. Sangay, no ash observed in satellite. Revenador, same deal there. So, activity not observed on the Ecuadorian volcano front. Don't assume that that means that they're not erupting. It could be cloudy. Sabancaya also exploding. Flight level 220. It's a 22,000-foot ash plume there. And Nevados de Chilean producing intermittent incandescences. A great reminder to please not pole vault the caldera. Please don't pole vault the caldera, folks. We need the views on YouTube. So tell your friends and foes about the channel. Tell them about smAsho.com. And remember, please do not pole vault the caldera. This public service message brought to you by me at massive personal risk and expense. Next, looking at the GOES X-ray flux. The GOES 16 has instruments that face Earth and some that face Sun. The sun-facing instruments includes X-ray detectors. And the red and blue lines are the long and short wave X-ray frequencies. No major flares over the past 3 days, as you can see there. No proton strikes as well. We do monitor it daily. And we endeavor to forecast this before you see a strike by forecasting coronal mass ejections before they leave the solar corona, and hence before they strike Earth. GOES magnetometer over the past 3 days is showing some wild spikes, and we do have a North Pole heliospheric current sheet showing up. Anyway, there's the 3-day chart on the GOES magnetometer. Some pretty significant magnetic perturbations showing up there. And again, keep in mind, folks, there is a stream of plasma on the way in the form of a coronal hole wind stream, and that will affect the GOES magnetometer as that plasma arrives. Also, there is a North Pole current sheet on the way. So here's the Gong 2 data. And you can see this green portion over here, perhaps. This green portion of the current sheet here is North Pole polarity, and that is showing up quickly. And based on this data, I would forecast that Sunspot 2833 is going to degrade, as the North Pole current sheet looks like it's certainly coming our way. Keep in mind this data is 1 hour and 47 minutes old and can change with absolutely no warning, as the magnetic environment can. Here's another view of the same data, the line of sight ecliptic plane field plot. And we'll also show you the coronal hole line of sight plot. And the source of that geomagnetic storm forecasted by NOAA is this coronal hole system right here. It's sending a stream of primarily protons, also some electrons and alpha particles, will be striking the geospace in about 2 days. Here's the El Teide intensity gram. And you can see Sunspot 2833 up here has remained pretty stable in the past several hours here. And the Integrated Space Weather Analysis Center is not yet fully operational, so that's why we can't show you the stereo A imagery. Let's take a look at global geomagnetism. The KP index currently at 2 for the past 12 hours. Next, real-time solar wind. And there's that. We did see some recent shifts in the BTBZ. That's the total field and the orientation of the field to one of the poles. And also shifts in the phi angle happening here in the past about 10 hours. Also a little uptick here in the solar wind density. Solar wind density now up to 26.32 protons per cubic centimeter. Solar wind speed 377 kilometers per second. Perhaps an early arrival of a coronal hole wind stream pulse there, as that is a significant density increase. So current solar wind density conditions, over 25 protons per cubic centimeter. If that is a coronal hole wind stream, expect to see the density drop and the speed rise. Current solar wind speed only 374 kilometers per second. Next, looking at the geospace over the past 4 hours, it's a model based on the space weather modeling framework. If you want to read about that, go to the Geospace Magnetosphere Movies page, scroll down, click on details. You'll have links there. And we see pretty homogeneous pressure here. Pretty homogeneous pressure over the last 4 hours, which is the data set we're showing you there. 4 hours of data in nanopascals magnetohydrodynamic pressure. Here's 4 hours of data of geospace delta B, perturbations on the ground magnetic perturbations, and we see some pulses coming out of the Pacific Ocean here north of Hawaii, which we actually regularly do see around the summer solstice, the June solstice, I'll call it, since we have viewers south of the equator. Anyway, that's 4 hours of data, ground magnetic perturbations, geospace delta B. It's all courtesy of University of Michigan. Now, we do regularly stream live to Twitch, and our meteorology and cosmology segment will have started out that way today. And let's talk about the electron flux. We do see some minor charging hazards here over places like southern Mexico, Central America, and the Central Pacific. Here's the 1-year chart of the relativistic electrons surrounding planet Earth. And here's a 3-day chart of it. We're seeing actually a little bit low levels here, lower than I forecasted yesterday, as I was off. I agreed with this forecast, and we saw flat levels of electron flux with respect to yesterday. We can expect a bit of a dip when the coronal hole wind stream arrives. I would still tend to suggest that we're going to see a little higher levels of electron flux here. It's really no big deal. Here's the total electron content forecast, showing you the electron density for the entire air column. And once again, with these low levels, we're seeing some nighttime electron flux anomalies and likelihood of some GPS errors in some odd places, especially around this time of frame, this frame of time. And continuing on, here's a diagram of the Van Allen belts. And next we're looking at the F ionosphere layer. So located at about 300 kilometers of altitude is the F ionosphere layer. Here's a visualization of that. You're looking at vibrational frequencies. The ionosphere represents largely the barrier between space and Earth. And in that area, there's a molecular soup of a lot of chemical reactions happening and all kinds of energy dispersal and attempts by the Earth-Sun system to reach static equilibrium. We're seeing some major anomalies here in the Northern Hemisphere. Right up here around the net north geomagnetic pole. Look at those anomalies up there. Those are something that I don't think we've ever documented on the channel before. So some ionosphere anomalies and more stuff about the ionosphere coming in the meteorology segment today. If you don't check out the meteorology segment, please do. Again, you can find all of our playlists at youtube.com/smashomash/playlists. Anyway, here's the latest image. And we're seeing anomalies once again here. Places like Eastern Greenland and Iceland are seeing ionospheric anomalies overhead right now. That latest image from 9:15 Universal Time. Here's a diagram once again showing you distances in kilometers and the location of the ionosphere, as well as penetration of electromagnetic radiation through the atmosphere layers, and temperatures of things like the thermosphere. Next, we're going to do a meteorology segment, and if you're only watching the Daily Space Weather video, make sure you check that out as well. Next, I'd like to thank our patrons, the true source of funding for the content, patreon.com/smashamash if you want all the earliest alerts, and all kinds of other perks like multimedia and GIF animations and custom ringtones and so on that nobody else gets to see. Patreon.com/smashamash. Thanks to our patrons. And if you're viewing the video, you should be thanking our patrons as well, as they are largely responsible for the existence and continuation of these videos. Let's take a look at the most recent hydrogen alpha imagery from El Teide, Spain. And I would say there is a coronal mass ejection watch in effect. So despite documenting one early in the video, there is likelihood of additional coronal mass ejections. We've got major filaments here. You can see filaments up here, filaments overlapping here behind Sunspot 2833. You can see dark spots down here, which are clearly filaments as well, even some in this area. So there is a lot of plasma in between the Earth and the Sun. Some of it's already on the way, and some of it is still suspended in the corona. The likelihood that it will eject is fairly high, which is why we have cited the coronal mass ejection watch. Here is our thematic image from the GOES 16. I like it. It shows all the features: coronal holes, filaments, prominences, bright regions, flares, etc. Again, I think Sunspot 2833 is going to degrade, if I had to guess, which I actually don't. Here it is in the intensitygram. And here's the latest colorized magnetogram. It's actually degraded since I did show prep, so it could shrink, although it's still quite a significant sunspot. Here's some close-up imagery of it in 94 angstroms. And last but not least, here's some more Solar Dynamics Observatory imagery in 171 angstroms. Thanks for tuning into the Daily Space Weather, and may that solar wind be at your back.